Basic sine, cosine, and tangent equations. So here's some helpful information. A summary of solving cosine x equals a tells you a falls between -1 and 1. Where a is not equal to 0, then we're going to have a solution of cosine x equals a. We'll have the solution. It says let s equal the inverse of the cosine, where k is any integer. And then it states, okay, if cosine x is equal to 1, then we have this one. If cosine of x is equal to 0, we have this one. And if cosine of x is equal to -1, we have this one. Absolute value of a, which means it's all positive numbers greater than 1. Then we have cosine of x is equal to a has no solution, okay? Then the basic sine equations. The summary of sine x equals a says that a falls between -1 and 1. A is not equal to 0. Then we get s is equal to the inverse of sine of a. And then we have the solution set of sine x equals a. We have these formulas here where s is either greater than 0 or s is less than 0. And then when sine x equals 1, we get this one, sine x equals 0, and so on, okay? And then we have the tangent formulas here that we will use as well, depending on what s is. And this here reads that s is greater than or equal to 0. So in this case, it can equal 0, where up here it says it's just greater than, and you either get greater than or less than. You don't get no equal to. So let's solve for example 1. We're going to find the real numbers that satisfy the equation of cosine x minus 3 equals -4. Okay, so before I can determine what a is, I need cosine of x by itself. And I notice I got this -3, so I'm going to add 3 to both sides. So now I got cosine x is equal to -1. So now I know what a is. So I'm going to rewrite it where I have the inverse. And so that means the x comes out front. And we get the inverse of cosine as -1. And when we plot it, we get pi, right? When the cosine is -1. When we go up to the top and we use our identities, well, we notice that a is what? A is equal to that -1. And we're going to find which formula to use. So we got the set builder that builds on x, where x is equal to pi plus 2k pi. And that would be the one we pick. So have that front page with you when you're working on the section. It will help you. We also know, and just to let you know that we know the inverse of cosine, the interval notation, it would be 0 to pi, which makes sense, right? So just have those out. Another solution could be pi to 2 pi again. So just have that front page out with you when you work through this. Let's solve for example 2. Find all real numbers that satisfy the following equation. So in order to do this, we need cosine x by itself. So I'm going to add this square root of 2 to both sides. So now I get cosine of x is equal to square root of 2. Now that I have that, I am going to go back to that rule up there, you know, where it states that if the cosine is greater than, less than, whatever it may be, and where the absolute value of a cannot be greater than 1, then if it is, then cosine of x is equal to a has no solution. So in this case here, we have no solution. A is the square root of 2. Okay. Number 3 says find all real numbers that satisfy the equation of sine equals square root of 3 halves. So what I'm going to do is I'm going to take the inverse of this. And I'm going to find where it falls on the unit circle, and I get pi thirds. So now I say, okay, sine of x equals a, we know is the set builder of x is equal to s plus 2k pi, or x is equal to pi minus s plus 2k pi. pi. So we know that. So we know that S is equal to the sine inverse of A. So what we're going to do, we're going to plug in what we know. Okay. So I got X is equal to the sine inverse of square root of 3/2. We know is pi thirds. We're going to subtract it from pi. So we're going to take this right here. We're going to take pi minus pi thirds plus 2k pi. And in order to subtract this here, I'm going to put a 1 underneath it. Common denominator is 3, so I need to multiply this by 3. So I get 3 pi minus pi over 3 plus 2k, or this should be a k, pi. So now I got 2 pi thirds plus 2k pi. So now I know. Okay. Remember that this was S equals, right? So we're just plugging in right here what S equals. So we had to solve for this last part here. So now I'm going to write my answer down here at the bottom. So I have the set builder of X that builds where X is equal to, and I'm going to plug in for my S. And then we have the OR. You may see it where they have it separated, or they may have it in the same line, you know. So just notice the notation. I'm going to write it the other way too. That way you may see it written like this. Or like what I just wrote above. So just know what you're reading. These are correct statements. All right. So let's work on the next one. The next one says, find the all real numbers that satisfy the equation cosine x equals 2 1/2. Okay, so again, we're going to go up to the top and we're going to follow the rules. It says that if A falls between -1 and 1 and A is not equal to 0, then we know we're going to use this here. And a half does fall between -1 and 1. So this is the one we pick. All right, so now let's find the inverse of that. So it gives me x is equal to the inverse of the half. And when I plug that in, I know I get pi thirds. And now let's just plug that into our work here for S. This first side it worked out great, right? So this is what I get. I'm going to put OR, and now I need to solve for this other side. I get 2 pi minus that pi thirds. So those are my like terms I have to. We still use basic math, guys, throughout this course. I'm going to have to add and subtract those. Actually, I'm going to subtract. I have to have a common denominator, and I notice it's 3. So 2 times 3 is 6 pi minus pi over 3. And then 6 minus pi, we get 5 pi, or 5 pi thirds. Plus 2k pi. Okay, so now I'm just going to write my final answer. And it's going to be we have this, and we have okay. So let's go to the next one. It's not so bad. Find all real numbers that satisfy the equation of cosine x is equal to the square root of 2 halves. So we're looking to see if it falls between that -1 and 1 for A, and A is that square root of 2 halves, and we'll see what it gives us. Yeah, it falls between -1 and 1, so we're going to go back to this here. We're going to use this one. All right, so we just got to find the inverse. Well, we know the square root of 2 halves is going to be pi fourths on the unit circle. So now that I know that, y'all can rewrite it as S is equal instead of X, because we know that's what we're plugging in there. And let's plug in. This other side, of course, we got to do some work, right? All right, we're going to find its common denominator, which is going to be 4. So now I get 8 pi minus pi over 4. And 8 pi minus pi is going to be 7 pi fourths. All right, so now let's go down. Got our final answer. All right, so we are good. So let's go on to our next example. Find all real numbers that satisfy the following equation. Okay, so we need tangent x by itself before we can do the inverse. So I'm going to subtract this from both sides. Oops. What's our notation here? And then I'm going to take the inverse. And what you can do is we know that when we take the inverse, we're going to put the x out front. But we can also say, oh, s is going to be equal to this. If this helps, because sometimes being visual will help you determine that. And remember, it's a negative square root of 3 divided by 3. And then when I plug it in, I get negative pi 6. And now, okay, based on that, it says that if your s is greater than or equal to 0, we're going to use a particular formula. If your s is smaller than, we're going to use a particular formula. So since it's greater, or excuse me, less than, since this here is less than 0, I'm going to use this one. So just make sure that you know which one you're picking. And then let's just plug in what we know and let's solve. Okay, we need a common denominator. In this case, it's 6. Right over here. So I get negative pi plus 6 pi over 6, which gives me 5 pi 6. And then we're going to add on the k pi. So let's write that here. Our final answer. Okay. All right. So let's do our next example. Find all angles in degrees that satisfy the following equation. So we got cosine alpha is equal to -1. If I take this and take the inverse of that cosine to get alpha, we're going to get 180 degrees. Okay, which makes sense. Look, it shows you. All right. So we know that the x coordinate is -1, which makes sense for cosine, right? Right there you get 180 degrees. That means the interval is 0 degrees to 180 degrees. Makes sense, it falls on the x-axis. So when we know that, then we can go, oh, okay, I know what I need to use now. So we've been using x, but we're going to say alpha, because in this case here, x has been replaced by alpha, is equal to the 180 degrees plus k. And instead of 2 pi, we're going to use 360 degrees, which makes sense, right? 2 pi is 360 degrees. And then we're going to say or alpha is equal to 180 degrees plus k 360 degrees. Well, it's pretty much what we got repeated here. There's just, oh, I see what I was going to write a notation on this right here. You could say 360 degrees k, or we could have had k first. Here's the thing. The reason it doesn't matter is because multiplication is commutative. So we have 2 times 3, which is 6, 3 times 2, which is 6. So that's why the k can go before or after the 360. But that would be my answer. Okay. Let's do the next one. Find all angles in degrees that satisfy the following equation. So in order to do this and determine what A is, we need the sine of alpha by itself. So what I'm going to do is I'm going to add the square root of 3 to both sides. Then that gives me 2 sine alpha is equal to square root of 3, but 2 is multiplied to sine alpha, so I'm going to divide by it. Now I got sine alpha is equal to square root of 3 halves. And now I'm going to take its inverse because I need to get it set. We know what A is. A now is going to be that square root of 3 halves. And now I'm going to take the inverse of the sine. And when I do that, I get pi thirds. And when I plug it into degrees, I get 60 degrees. Now that I know that, I got everything I need. I got it written in this format. I know what A is, and I got to determine if A falls between -1 and 1. So what we'll do is take the square root of 3 divided by 2, and we see it does. It falls between -1 and 1. So I know what formula I want to use. So we're going to use the, let me write it down right here, or the identity. I said formula. Oops. It's for 180. There we go. There we go. 180 degrees minus S plus K of 360 degrees. And then we just plug in what we know. On this side here, we got to do some basic math. So we got 180 degrees minus the 60. So that is going to give me 180, which is 120. Okay. Okay, so that is our answer. All right. Okay, so now let's do our next one. Find all angles in the interval of 0 degrees to 360 degrees. It satisfies the equation given to us right here. Oops. Okay. So what we're going to do is we're going to take its inverse. And when we take its inverse, we type it in our calculators, round to the nearest tenths. And when I do that, I noticed that it said that 360, so 0 to 360 degrees. So I'm going to take that 360 degrees, subtract the 80.6 degrees, and I get 279.4 degrees. That would be my answer. Okay, number 10 says find all the real numbers on the interval of 0 to 2 pi that satisfy the equation. So we're in radians now. So make sure whenever you work these, you know, whatever you're in, degrees or radians is what your calculator's in. So I'm going to solve for tangent x. I got to add the 1 to both sides. And since the square root of 3 has been multiplied, I'm going to divide it. So now I got tangent x is equal to 3 square root of 3. So I'm going to take its inverse. And type that in the calculator. We get approximately 1.05. Be careful because the rounding, if we didn't round here, our answer would be different later on. So just be careful and read whatever the homework assignment is. If it tells you do not round until the very end, then I wouldn't round this. Just make sure and read what it asks us for. So now what I'm going to do is I'm going to take the pi minus that 1.05. And I'm not going to round this one too close to the whole number at all yet, just because of the number could be off by thousands of points. So I got pi minus that, and now I'm going to say 2 pi minus this answer we got from that one. And this is keeping us within the 0 to 2 pi range. I'm going to round to the nearest hundredths. So this would be my answer. So just make sure and read your homework assignment on the rounding, okay? All right. The next one is to solve the following, where beta falls between, and it can equal negative 360 degrees to 360 degrees. So that means we need to solve for beta. In order to do that, we need to find cosine of beta. So I'm going to add this 5 to both sides. And 5 times that cosine, I'm going to divide. 5 divided by 5 is 1, and now I'm going to take its inverse. I'm going to do that. I'm going to type it in the calculator, I get 0. And if you go to the computer, you'll notice that cosine of 1 falls at 0 degrees. So my answers here is 360 degrees, the negative of it. It also will be 0, and it also be the positive of it, because it says that it can equal it. Okay, let's do our last one. Our last one now, we got a little bit more work going on. I noticed that I got sine here, and I got sine here, and then I got constants. So let's get the constants on one side and the sines on the other. So I'm going to subtract the 8 square root of 2 from both sides. And then I'm going to subtract the 6 sine of beta from both sides. Okay, so now on this side, I got 4 sine beta minus 6 sine beta is equal to 9 square root of 2 minus 8 square root of 2. So 4 minus 6, that's going to give me a negative 2 sine beta, and then the square root of 2, because 9 minus 8 is 1. So now what I'm going to do is I want to get sine beta by itself, so I'm going to have to divide by that negative 2. So now I got sine beta is equal to negative square root of 2 halves, and I'm going to take its inverse. All right, when I take its inverse, I find that beta is going to be a negative 45 degrees. Sine is odd. So now that I know that, what I can do is take that 180 degrees, subtract that negative 45 degrees, which means I get 180 degrees plus 45, which is 225 degrees. So that's one answer. And then I'm going to take that 360 degrees, and I'm going to just subtract the 45. I'm going to do that. I get 315 degrees. So I get 2 answers there, and that's it. So just basically read the instructions.